In this video, we have a couple of examples of logarithmic equations. The first one is 1 minus log of x minus 2 equals log of 3x plus 1. Now these are both log base 10. If it's not written the base, then it's implied that it is base 10, whereas down here, the ln, the natural log, is implied that it's base e, the natural base e, which is 2.718 dot 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 dot. Okay, on to this first one. So if you have this, you want to get the logarithms together, so you'll add the log of x minus 2 to each side, and you get 1 equals log of 3x plus 1 plus the log of x minus 2. Now using properties of logarithms, the sum of two logs equals the log of the product of what's inside here. So I'm going to write that. So that gives us 1 equals the log of 3x plus 1 times the quantity x minus 2. And then I've just multiplied that here. So the log of 3x squared minus 5x minus 2. Now the trick is, this is log base 10. So we can pull this little property of logarithms. 10 to the first power equals 10 to the log of all of this stuff. And there's a property of logarithms that says that if you have some base b and you raise that to a power of log of the same base b, that anything that's inside that logarithm, that just equals that inside. So this is our m in this case. So 10 to this log of base 10 of all this stuff just equals all this stuff. So, and 10 to the first power on the left hand side is just 10. So we have 10 equals 3x squared minus 5x minus 2. Now we're rid of the logarithms, so we can just write 0 equals 3x squared minus 5x minus 12. And that factors as 3x plus 4 times the quantity x minus 3. So we have our solutions. X equals negative 4/3 and x equals positive 3. Now, we, of course, have to throw out one of these solutions, and that's the negative 4/3, because if we plugged in negative 4/3 in here, we'd be taking the logarithm of a negative number, so we can't do that. So even though it solves this equation, we have to remember that in the beginning we did start with logarithms, so we have to cross that one out. But the x equals 3 works just fine. In our other equation, natural log of x equals the natural log of 2x minus 1 minus the natural log of x minus 2. We don't have to pull any of this taken to the power of stuff. All we have to do is just say the natural log of x equals, now we're going to rewrite this, the difference of logarithms equals the logarithm of a quotient. So it goes like this. The logarithm, the base stays the same. Now it's 2x minus 1 in the numerator over x minus 2 in the denominator. So we have that. So now, if the logarithm of this x equals the natural logarithm of this stuff, then we can just say x equals all this stuff. So I'll write that next. And now we can cross multiply and just say x times x minus 2. So that's x squared minus 2x equals 1 times 2x. So that's 2x minus 1. Now we've got an equation. It's quadratic, but we can go with it. I'm going to change colors just so we don't confuse the situation here. So I'm going to subtract 2x from each side, and I get x squared minus 4x. I'm also going to add 1 to each side, so plus 1 equals 0. And we're going to have to factor this. And we find that it does not factor. So we can use that quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And in the end, then what we get is we're going to have to cross out the negative answer. We're going to get 2 plus or minus the square root of 3. But we're going to have to cross out the 2 minus the square root of 3 because of the same reason we had to cross out the negative here, because we'd be putting in a negative in there. 2 minus the square root of 3 is something that's actually a positive number, but it would give us trouble in one of these other ones, and it's this one right here. It's the x minus 2. And so